Hey everyone! In this video, we're going to explore hybrid search. We'll break down exactly what it is, why it's such an important concept, and how you can leverage its power using Vertex AI Vector Search. Let's dive in. Retrieval Augmented Generation, or RAG, is a popular way to build AI applications these days. It's like giving your AI a sidekick, a retrieval engine. This retrieval engine finds the relevant documents and data for user questions. That way, the AI can give up-to-date answers and is less likely to just make things up, so-called hallucinations. When it comes to retrieval, vector search or vector databases are the popular choices because of its semantic search capability. Let's quickly recap how the semantic search with vector search works. Embedding models create a vector space that maps the meaning of texts. Think of it as a map where each text is a point representing its meaning. For example, if a model analyzes a text discussing movies for 10%, music for 2%, and actors for 30%, it might represent it with the embeddings 0.1, 0.02, and 0.3. Vector search allows you to quickly find similar texts by searching for the neighbor on this map. This is called semantic search, and it's based on meaning, not just keywords. Semantic search is so powerful. For example, if you search for movie, a vector search can also find relevant texts with film and cinema because the embedding model understands they have similar meanings. This leads to improved search quality. While semantic search is so powerful on finding text by their meanings, it does have a weak point. It excels at understanding the meaning and context of words, but it can struggle with information that falls out of domain. Essentially, data the embedding model hasn't been trained on. Think of it this way. Semantic search can only find what it already knows. So if you're searching for something like a specific product number, a brand new product name, or an internal company code name, semantic search might come up empty. These types of data are often unique identifiers, or newly coined terms, and they're unlikely to be included in the vast datasets used to train embedding models. That's where hybrid search comes in. By combining the power of semantic search with traditional keyword search, you can get the best of both worlds. Semantic search can handle the nuanced, contextual queries, while keyword search can effectively capture those specific out-of-domain terms. This hybrid approach ensures a more comprehensive and accurate search experience. Google Search is one of the most popular hybrid search systems. In 2015, it incorporated semantic search with the RankBrain model, enhancing its existing keyword search algorithm. This hybrid approach significantly improves search quality by effectively addressing two key requirements, searching by meaning and searching by keyword. But building a hybrid search engine used to be quite a feat. Imagine having to build two separate search engines, like Google does, one that understands the meaning of your words and another that focuses on specific words themselves. Then you'd have to combine the results from both and figure out how to rank them. It was a complex process. Vertex AI Vector Search now supports hybrid search, making it easier than ever to build a custom search system tailored to your specific needs. With a single index, you can combine the power of semantic search with traditional keyword search for optimal performance. Let's take a look at how the keyword search works with Vertex AI Vector Search. The keyword search is called as token-based search because it works by splitting the text into individual units called tokens, which can be words or subwords. These tokens are then used to create a vector called sparse embedding. Think of sparse embedding as a long list that shows how many times each word or subword appears in the text. The sparse embeddings generally don't consider the meaning of words. They merely represent the frequency of each word's appearance in the text. Since there can be thousands of different words in a text, the embedding can have tens of thousands of dimensions, but only a few of these dimensions will have non-zero values. This is why they are called sparse. Most of the values are 0. The sparse embedding space acts like a map of keywords, similar to an index in a library. In this sparse embedding space, similar embeddings can be found by examining the neighborhood of a query embedding. These neighboring embeddings share a similar distribution of keywords within their corresponding texts. This mechanism underlies token-based search using sparse embeddings. Let's explore how to use token-based search with Vertex AI Vector Search, using a sample dataset. In this example, we will use 200 items from Google Merch Shop dataset. We begin by using a vectorizer to transform our text into sparse embedding. In this example, we'll use a TF-IDF vectorizer from the scikit-learn library. TF-IDF is a common algorithm that gives more weight to important words within a text. This function takes the text like Chrome Dino Pin and feeds it into the vectorizer. The output is 3 values with their dimensions. This is the sparse embedding for the text. Next, generate a sparse embedding for each item in your dataset. Store the resulting JSON file in cloud storage and use it to build a vector index with Vector AI Vector Search. To query a sparse embedding index, create a hybrid query object that encapsulates the sparse embedding of your query text. This retrieves items containing specific words, like kids. This demonstrates how to use token-based search with vector search. Now we can improve our search by combining the strengths of both token-based and semantic search. This hybrid approach will allow us to find relevant results based on both the exact keywords and the meaning behind the query. With Vertex AI Embeddings API, you can effortlessly generate text embeddings for any given text. Just like in this code, these embeddings, used for semantic search, are also known as dense embeddings. The dense and sparse embeddings should be stored in a JSON file. This file will be used to build the vector index. After the index is built, it can be deployed to an endpoint. The endpoint will then be ready for use. To perform a hybrid search using both dense and sparse embeddings, create a hybrid query object that encapsulates both embedding types. This object will then execute a search query, leveraging both the dense and sparse embeddings. Here's the result of the hybrid search. As you can see, the items with higher similarity for both dense and sparse embeddings appear at the top of the list, such as Google Blue Kids Sunglasses. Items similar to either the dense or sparse embeddings are following after them. For example, Google White Classic Youth Tee is ranked in the middle because, while it doesn't contain the keyword kids, the keyword youth tee is semantically similar enough to be included in the results. To combine the results of semantic and token-based searches, vector search employs an algorithm called reciprocal rank fusion, RRF. In this video, we learned about hybrid search, its benefits, and how to use it with Vector AI Vector Search. By combining semantic search with traditional keyword search, we get the best of both worlds. Semantic search excels at handling nuanced contextual queries, while keyword search effectively captures specific, out-of-domain terms. This hybrid approach ensures a more comprehensive and accurate search experience. If you're interested in hybrid search, please check out the resources to get started. Thanks for watching!